right. So today we're going to start talking about inverses. And here we go. All right, so an inverse will undo what the original relation or function did to the problem. So like if you plug in a 2 and you get a 7, the inverse would take the 7 and turn it back into a 2. And so every inverse relation can be found by switching each x and y value. So in some situations, you can just kind of do this in your head. Other situations, it's going to be more algebraic stuff that you have to do. But it is important that you understand the concept of the inverse. Because I always think it's helpful if you understand the purpose, so that way you can kind of remember what you're supposed to do. So we're going to look at inverses 3 different ways. Today we're going to do numerically using the tables and analytically using the algebraic equations, and then tomorrow we'll look more at finding the inverses using the graph. Okay, and so on example 1 we have a relation that takes the 1 and turns it into a -1, and the 3 turns it into a 2. And so if we want to find the inverse relation, it's actually like the easiest thing you've ever done. You just take the x's and you make them all y's, and take the y's and make them all x's. So it's literally just switching x and y. With the given information we have about this table, so we don't have all the values of x, but with what we're giving, would you say that this is a function? Yes. It is. Because each input has exactly one output. All right, what about the inverse? Would you say the inverse is a function? No. And the number that, or the input that messes it up is the 2. So 2 is paired with 3 and 6. So a good portion of tomorrow's lesson, we're going to be talking about if a function is invertible, or the function's inverse is also a function, and so that's what the majority of tomorrow's lesson is going to be covering. So in this case, this function is not invertible because when you do the inverse, it's not a function. All right, so let's look at doing this analytically, which I think is what you mainly focused on in Algebra 2. And so it's depending on the type of function, it could be varying levels of difficulty, but what we're going to do always is just switch x and y. And so in this case, we don't see y, but y is f of x. So we're going to make that x and make your x y. And then you're going to solve for y, which this is where sometimes it's difficult, sometimes it's super easy. This one is pretty easy. There's just a 2-step process to solve it for y. So first you would add that 7, and then you would divide by 3. Now, I would leave this as one big fraction. So you can, if you want to, divide each of those by 3, but I don't think that's helpful really. And then your last step is, if this original problem was written using function notation, the answer is going to be written using inverse function notation. So that's going to be f to the -1 of x. That means the inverse function of f is just equal to that x plus 7 all over 3. All right, so the inverse function of f is written as f raised to the -1 of x. You don't really say it that way. You would just say f inverse of x. All right, you guys remember that from last year? Kind of? I hope so. If not, we're going to do lots of examples, so don't worry. was weird. Okay, let's look at example 3. So same thing. We are going to switch x and y. And then we're going to solve for y. So this one is going to be a little more challenging to solve for y. What would you guys do first? Absolutely. Right. Now we can't get to this y if there's a power on the outside of the parentheses. So how do you get rid of a cube? Cube root. Thank you for saying that. They said the third square root last period. Don't ever say that. It's the cube root. All right, so we're going to do the cube root of both sides. All right, and then last step is just to add that 2. Now, if you guys notice, this one didn't start off as f of x, so we're not going to call it f inverse of x. We're just going to call it y, and that's fine. It doesn't matter. Bless you.
Bless you.
All right, now let me ask you a question. Can I add that 2 to that -4? Absolutely not. So it's just going to be the cube root of x minus 4 and then a plus 2 on the outside. That's the inverse. All right, so it would take whatever this input value is, whatever output value, you could put it here and it would turn it back into the original number. Okay. Now I feel like you guys did ones like that. You did linear, you did cubic, you probably did like square root or whatever in Algebra 2, but I don't think you did rational function inverses in Algebra 2. It's the same thing. You switch x and y and solve for y, but the solving for y process is just a little bit different and it's not something you're probably super familiar with. So I'm just gonna, as we do these steps, we'll talk about the steps as we do them. But first step is exactly the same. You switch x and y. What's weird is that there's 2 x's, so there's going to be 2 y's. And so if you were just solving this on your own, you might get to this point and just kind of freeze and just not really know what to do. But I talk about this a lot in all my classes. If there's something in the denominator and you don't want it there, because we have to solve for y. We can't solve for it when it's in the denominator. What do you do with it? You just multiply by it. And so that's what we would do. We would just multiply by that denominator. Now, I'm going to go ahead and distribute it. If you wrote it already with the parentheses, you can distribute that x.
Is there a certain way that x and y have to be set up? Or can it be yx, xy?
No, it doesn't matter. All right, I usually write it in alphabetical order, but there's no logical reason behind that except just my brain. Okay, so we have done step 1 and step 2. So we multiplied by the denominator and we distributed to get rid of the fraction. And now step 3. So what we're going to do on step 3 is move all terms that include a y to the left side and all terms that don't have a y to the right side of the equation. So this is just rearranging, and just remember, when you move something across the equal sign, it has to change the sign. So if it's positive on the left, it's going to be negative on the right. All right, and then step 4 says to factor out a y, it says and y, but factor out a y from the terms on the left side of the equation. And so both of those, everything on the left should have a y, so we factor it out. And when you do that, you're just dividing each of those by y. All right, and then we want to solve this for y. So you can read the step, or we can just think about it. So this is y times this parentheses. If we want to get rid of that, what would we do with it? Not subtract it. We would divide by it, right? And so that's step 5. Divide both sides by the terms remaining after you factored out y. Right? And then we're going to write our F inverse notation. All right. So that is the inverse. So some of the ones, like the linear ones and maybe even the cubic ones, you could kind of go through the process in your head and do it. You can't do that on rational. You're going to have to do all the things. All right, so just a reminder of what an inverse is. So I should, like if I put 2 in for x, what would you get? Like what is f of 2? 0. So what I should be able to do on this one is put 0 in, and it would give me back the 2. That's the whole purpose of an inverse. All right, so you guys want to try B on your own? All right, I'll be working it up here silently so you can check as you go. All right, what questions do you guys have? Oh, some of you are still working. It's okay. Keep going. Okay, so I got one more reminder about what an inverse does. It's important to me that you understand this. So usually you plug a number into a function, you get a different number out, the output. So if we took x equals 2 and we put it into this function, what would we get? 5. So then, if I took that 5 and we plug it into the inverse function, what should you get? Yes, good job. All right, so because of this, there is a way that you can show that two functions are inverses. If we plug the x into the function, take that output, plug it into the inverse, we should end up with x again. So that's kind of like doing a composition. And so to show that two functions are inverses of each other, you do f of g of x, and you should end up with x. And then you do also g of f of x, and you should end up with x. So we must show that the compositions of both equal x. All right. Now I'm not going to do all 3 of these examples unless you guys just really feel like you need them. So I'm just going to do 5 and 6. I think that should be plenty. All right, so on 5, we want to determine if these 2 functions are inverses of each other. And to do that, we're going to do the composition. So first, we'll find f of g of x. So I'm going to just take that g of x, I'm going to put it in parentheses, and then I'm going to put it into f, which means I'm going to multiply it by 2, and then subtract 3 from it. Now, I know you guys are really, really smart, and I've been doing this a long time, and I'm going to show you what people do that they won't get points for. So everybody knows that this should end up being x, and so this is what people do. They just do slash, slash, slash equals x. Don't do that. Let's do all the steps. So if we follow the order of operations, so if we were following the order of operations, would we multiply by this 2 first, or should we try to subtract 3 first? Multiply by the 2. So distribute the 2. So 2 times 1/2 x is just x. 2 times 3/2 is 3. And then subtract the 3's. And you are left with x, which is what we needed. If they're inverses, that's going to happen. All right, and then we need to do it the other way also. Now, if you haven't been here, then you might not really know what compositions are, but you'll get caught up eventually. All right, so we're going to put, this time, we are going to put f into g. And everything I put into g, I'm going to multiply by 1/2. And then I'm going to add 3/2 to it. All right, so actually do that multiplication. So it's going to be x minus 3/2. And then you can do negative 3/2 plus 3/2 is just going to give you x in the end. Okay. Okay, so let's do this very last one. Let's do example 6. So sometimes there is a restricted domain to ensure that 2 functions are inverses. So these are only inverses when x is greater than or equal to 10. If x is less than or equal to 10, it doesn't work. But that's already taken care of for you today. So we'll just go ahead and show that they're inverses by doing h of k of x. Whoop. So we're going to put k into h by squaring it and then adding 10 to it. And again, I know you guys are smart and you're going to know that everything's going to cancel out and you'll be left with x, but please don't do that. actually do the things where we square that square root, and you're just left with x minus 10, and then you have the plus 10. And then those 10s should subtract away, and you're just left with x. Okay, and then to absolutely verify it, you have to show it both ways. So we have to put h inside a k. So what would you guys do first? Would you do the square root, or would you subtract the 10s? You would actually subtract the 10s first. So we take care of what's under the square root first, combine like terms, and then the square root of x squared is just x. Okay, what questions do you guys have?
So we have to write they are or inverse?
No. Well, I think it just says to verify that they are, show that they are. So, you're good. All right, any other questions?